Okay, let's talk about an example of this, okay? So let's say I have 3x plus 7, okay? What is our variable? What is our coefficient? And what is our constant, okay? In this example, 3x plus 7, our variable in this one is x. Our constant is this plus 7 at the end, and the coefficient is the 3 that's in front. An algebraic expression is all of these things together. So an algebraic expression involves a variable usually. So like 3x plus 7, all of that together is an algebraic expression. Let's start with those definitions and we'll come back to the last couple, okay? Identify each part for each one. This one has lots of examples. So is there a variable? Yes, our variable is x. Do you have any constants? This plus 9, that is our constant. That's 9. Now, do I have a coefficient? Is there something in front of that x? Yes, there is. We don't see a coefficient. There's no number that we can see, but secretly there's a 1 there because there's one x. So this is a 1. Okay, let's look at the second one, number 8. Are there any variables? Yes, we're using the letter m instead of x. That's okay. Are there any constants? I don't see any plus or minus on here, so there's no constants. And the coefficient, what number is being multiplied by the variable? In this instance, it's 5. Number 9. So this one's out of order. So usually we've been seeing the variable first, and then we're seeing plus or minus the constant. So we can reorder it because in math, order of addition doesn't matter. So I could say it's equal to p minus 7 if that helps. So my variable on this one is p. I have a constant. I have this -7, and it was in front, and I moved it to the back. Either way is okay. However, it was comfortable for you to look at it. Coefficients, again, I've got p, and I don't have any number in front of p, but there is a number, because how many p's do I have? I only have one p. Okay, number 10, and then the rest, let's do number 12, because that's the hardest one. Variables, and I'll leave 10 and 11 for you to practice on your own. Variables. We're using y in this one. And then I have any constants. I've got this -10. And then I've got my coefficient. I have a -4 in front of y. So I'm careful to keep my negative sign to go with it. Okay. Okay, we are matching the algebraic expression to the words that go with it. Okay. A, the number of wheels on a bicycle, B, bicycles. So we're looking for something with B as a variable, and we only have one option, and it tells us the number of wheels on the bike is 14. This one involves B, right? And that makes sense because 2 times B, a bicycle has 2 wheels. So if I have 10 bicycles, I've got 10 times 2. So I've got 20 wheels. So it represents the words in an algebraic form. Okay, let's look at, I got that one. What about B? The cost of buying 5 notebooks at $D each. So it's going to involve dollars. And if I bought 5 notebooks, it'd be 5 times 5, or 6 notebooks would be 6 times 5. And I'm looking for something involving D. Oh, I wrote the wrong variable thing down here. Let me erase. I wrote B when I should have wrote A because it was the B variable. Let me take that out. This is A. Sorry about that. And now I'm looking at B, which involves the variable D. So the dollars for $5, 5 notebooks at $D each is going to be 15. B. C, your age in 10 years if you're currently Y years old. Okay, is this going to be adding, subtracting, or multiplying? We know it's going to involve Y, and my age in 10 years is going to be my age plus 10 years. So if I look for something that involves Y and also plus 10, I get this one right here. D, number of pizza slices left from a pizza with 8 slices after eating S slices. So if I gobble up 5 slices and I had 8, it's going to be 8 minus however many I ate, and I ate 5, so it'd be 3. So I look for something involving S and also 8 minus that. So that is this one. And D, the perimeter of a square with side length X. Okay, so the perimeter of a square is the outside edges. There are 4 edges for a square. And if I want the perimeter, I'm going to add all of those up, or I could multiply the number of edges by 4 because there's 4 of them. And that makes this one E. Evaluating each expression. This was one of our vocabulary words. Evaluate means we plug in the number. So we're going to plug in 7 for A. So every place we see A, we're going to replace it with 7. So I get 7 plus 15, which is equal to 22. Okay, let's look at the next one. Evaluate C minus 8 when C is 20. So I'm going to replace C with 20 minus 8. That's 8 equals 12. Okay, I'm going to skip around and leave some of them for y'all to do. Let's do 22. 25 minus 4K. So I'm going to replace K with 3, and I'm going to use order of operations. So I'm going to multiply first, and I get 25 minus 4 times 3, which is 12. And 25 minus 12 is 13. Amazing. Okay, let's do 23. Evaluate P divided by 10 when P is 40. So I'm going to replace P with 40, and I get 40 divided by 10. 40 divided by 10 is 4. Okay, I will skip number 24. Let's see. Let's do 25 together. An expression 3C minus 7 gives the cost in dollars in order of ordering custom t-shirts, where C is the class size. You evaluate the expression when the class has 15 students. So I'm going to replace C with 15. So I get 3 times 15 minus 7. And again, I'm going to use order of operations. And I added an extra parenthesis, but I'm going to take off. And so I get multiply first. 13 times 15 gives me 45 minus 7, which equals 38. And then this already has dollars on there, so I don't have to write that. But if it was a test, we want to make sure we include those units. Write an algebraic expression for each situation, then evaluate. Ooh, this is harder because this is talking about word problems and making word problems into an expression, but I have confidence we can do this. A parking garage charges $8 an hour. Write an expression for the cost of parking for each hour. So we ask ourselves, is this multiply, divide, add, subtract? So it charges per hour, and I'm parking for 4 hours. I'm going to say in my head, I'm going to multiply. So sometimes it helps to think of a real world scenario. Okay, so my expression is 8 times H. So H is the number of hours, and I charge $8 per hour. And then it says evaluate when H is 5. So I have to replace H with 5 and plug that in. I get 8 times 5 equals 40. And I check it. It's a word problem, word solutions. It's asking me write an expression for the cost. So the cost is in dollars. Maria has $50. She buys lunch for $12, then spends D dollars on a book. Write an expression for how much money she has left. Okay, so let's think about this. Okay, so she starts with 50, then she buys lunch, and then spends D dollars on a book. Okay, so she's spending money. So those are negative occurrences. So if we look at this one, we can say we start at 50, and then we subtract 12. And then we subtract D. And I don't really need my dollar sign there. I'll leave it for the end. But I can simplify this expression by combining things that match. 50 minus 12 gives me 38 minus D. This is my simplified expression because I combine 50 and 12. So that's my expression, 38 minus D. And then it says evaluate when D is 18. So I'm going to plug that in. And I get 38 minus 18, which is equal to 20. And this one does say how much does she have left, how much money. This is dollars. Okay, let's try. I'm going to leave a few for you to try. Let's try number 30. A movie theater has 300 seats. Write an expression for the number of empty seats if T tickets have been sold. Okay, so this adding, subtracting, or division, multiplication. I have 300 seats. And then we're trying to figure out how many empty seats I have. So if I no tickets, I have 300 seats, empty seats. So I'm going to subtract out how many tickets I've sold. So I'm going to have 300 minus T is my expression, and then evaluate when T is 175. So I get 300 minus 175 equals 125. And those would be tickets if we're using units. Awesome job. Let's see if we have more. Oh, there's more. Complete each table by evaluating the expression for each one. Okay, so I've got 8 x plus 8. So everywhere I see x, I'm going to replace it with my value of x. So I've got 5 plus 8 for my value of 5, and my result is 13. So now I've got 10, so I'm going to replace x with 10 plus 8. And I get 10 plus 8 is 18. 0, I'm going to replace x with 0. I get 0 plus 8. 0 plus 8 is 8. I'm now negative 3. Negative 3 plus 8 gives me negative 5. Nailed it. Okay, I'm going to let you do 32 on your own. And we will do, let's see if we have any more. I will let you do both of those on your own. Challenge problems. Marcus says the expression 9 plus k. 9 is the coefficient. Is Marcus correct? Explain your reasoning. Let's look at this one. It is in opposite order we normally write. So let's write it the way that we normally look at it. We look at it like k plus 9. So 9 to me looks like the constant. And my variable k is my variable. And what's my coefficient that's in front of it? K. In front of K, I have a hidden 1 is my coefficient. Okay, number 35, right? 3 different expressions that all equal 12 when x is 3. Okay, I will write 1, and then you all can write 2 on your own. Write an expression when x is 3. Answer will be 15. I'm going to choose 1. I'm going to say 3 times 5 is 15. So if I said my expression is 5 times x, when x is 3, I get 3 times 5. So 5 times 3 equals 15. So this is one example, and you can come up with some more. The expression 2L plus 2L plus 2W gives the perimeter when the rectangle is L length and the W is the width. Identify all the variables, constraints, coefficients on this expression. Okay, let's see. What are my variables? My variables are L and W are variables. Two is my coefficient for both. And do I have any constants? No, I do not. And that's so many things. Okay, I will let you try the rest of them on your own, and I will hope you enjoy a great weekend, and I'll see you in class.